This rather long-winded discussion is about a 196 scale Albacore model that I assembled from parts provided by a friend. I supplemented the build with my own parts created from masters and tooling, and then laid up resin parts. The eventual model is now operational. It's a proper scale model that's radio controlled capable, and what you're looking at here is, of course, the actual submarine itself undergoing trials, what appears to be in the Phase 2 configuration. It went through at least 5 phases of operation, each phase denoting a particular design alteration to test and validate ideas developed to David Taylor and then implemented on this research submarine. It's a non-combatant and was created in the early 50s and operated, I think, until sometime in the 70s. It retired only because the engines that it employed were basically obsolescent and there were no repair parts. It is now a memorial or a display submarine which can be visited to this day. Built and commissioned in the early 50s and did a lot of fundamental research in hull design, control surfaces, interactions, even a rather exotic counter-rotating propulsor. Anyway, Scott Terry and I collaborated and produced a couple of kits, one for him, one for me. And this is the end result. My participation basically was coming up with a watertight cylinder to operate the submarine, and Terry did the heavy lifting on making the masters, patterns, and tooling, and produced a fiberglass hull and a proper set of control surfaces. I kicked in a sail, which represented the Phase 4 configuration. I believe the Albacore went through 6 configurations denoted as phases. Phase 1 through, I believe they got as far as 5 or maybe 6. They got as far as polymer injection to make the hull slicker for faster speed. At that point, the Navy figured they had done enough with it. And the unavailability of the main engines, because they used unique vertically oriented radial diesels, which were a bust. And as soon as they ran out of parts, they decommissioned the boat. Fortunately, it survives today as a museum. You can actually go aboard this thing. And this reflects the condition it is today, at least externally, Phase 4. One other thing before I remove the upper hull to get access to install this, I'm going to go ahead and do a little preemptive maintenance. I'm going to apply some oil to the oil light bearings of both propellers. There we go. I'm going to wipe off the excess. Like so. Good. And I'll oil the inboard bearings as well. So the time has come to remove the upper hull. Now you see the brake. This is the traditional Z brake. You got the radial brake forward well aft of the bow, you'll notice. I do that so that it makes for a more stable structure if you do that. So we've got the radial brake forward, we've got the radial brake aft, we have the longitudinal brake here, both sides of course. And in this stand I want to support the lower hull, so I make sure the lower hull is secured on the stand fore and aft. And then I can remove the single retaining screw back aft, like so. And then it's a simple matter to lift the upper hull piece off, like that. Okay. Now what's revealed, of course, are the innards less the cylinder. These two dog bones interface between the two drive shafts and the back of the cylinder, the outputs from the two motors. The motors are direct drive, no gear train. You can see how small propellers are. The Germans taught me decades ago that if you want to size the propeller to a motor and it's going to be direct drive, then if the propeller diameter does not exceed the diameter of the can of the motor, then you can do that and get away with it. And I've followed that principle for decades, and it's served me well. So a little hint from our German friends. Now you notice that the outboard shaft is driven here through this gear. And you'll notice that the after propeller is not engaged. But if I turn this one, that engages the after propeller. So what they do is they work in tandem, like that. Two motors, two inputs to the shaft, and we get counter rotation. It was during the Phase 4 period of test and evaluation that the Albacore was outfitted with counter-rotating propellers. You had one outer shaft, and concentrically running within that was another shaft. So you could achieve two different propellers going along the same thrust line, counter-rotating, which negated torque, but more importantly increased the efficiency of the combined propulsor by recovering some of the swirl energy. The initial test was a long distance between the two propellers. It was, I think, about 10 feet. And then they went through progressive shortening of that distance to see if there was any significant change in efficiency or perhaps improvement as a consequence of shortening the distance between the two propellers. The model master you see atop this picture here shows the short version, but I also built a long version, which is what I actually put into the model that Scott and I now enjoy. What we have here is some of the drawings I was using as source material and the long distance arrangement of the counter-rotating propellers. These are masters, which were fabricated by cast metal for the blades and wren shape for the hubs, as well as the distancing piece between the two propellers. I've amazed quite a bit of information over the decades on the Albacore, so I had at hand everything I needed to render accurate parts for this model. Of course, the polarity of the motors has been directed to give me the desired counter rotation. So to make up the cylinder, I first install this piece of Velcro, which will secure the cylinder in place. Something so simple as installing that's turning into a big deal. There we go. Yeah, time for a tool. There we are. All right, we got the strap in place. The starboard dog bone. These are shaft extensions or intermediate drive shafts, if you will. And then what I do is I engage the dog bones, like so. Of course, I'm rather studied at this by now. I want to make sure that these guys are out of the way. Notice how they automatically engaged, huh? All right. I've made sure that the indexing pin, which secures the cylinder to the lower hull, keeps it from rolling or moving longitudinally. And what holds it down in place, of course, is this magic Velcro strap, like so. Just rotate it all the way. So there we are. We've already made up the control surface linkages, and we've made up those. Now I'm going to squirt a little oil onto the oil light bearings on the inboard side. And we're ready to turn things on. I'm going to temporarily move this guy out of the way. There we are. All right, so I'm going to take this guy off the stand so it's sitting relatively flat because I don't want the angle keeper to go crazy. All right, let's turn this dude on. Transmitter. System. Right now the boat has got a bit of a up angle, so I see deflection already, and I'm going to go ahead and shim this thing up. Up, down, right, left, or for your purist, starboard, port. Up, rise, down, dive. Okay. And I'll put the transmitter down and demonstrate operation of the angle keeper. We pitch down, that says, oh no, we can't have that. Let's pitch back up. And vice versa. Let's wiggle the propellers. Yeah. So there we go. Counter rotation. All right. And then, of course, you see the anti-heeling operation of this servo push rod, which magnetically couples to this push rod here. And you can see its operation here, moving back and forth. You can make out the dorsal rudder moving. This magnet engages this magnet. So anyway, here's the condition of the model after it's been prepped and pre-missioned and everything. And the operations to turn it on are to turn on the transmitter, wave the magnet over the magnetic switch, which is just underneath the hull. There we go. I heard a little buzzing there. Okay, it's working. All right. Well, a function test isn't a function test unless it's in the environment it's supposed to function in. Wah-wah. Let's put it into wah-wah. Like so. Notice the dorsal fin. See how the thing's wiggling as I roll the boat? It's got a little bit of a port list. We're going to have to fix that with some foam. So what I'm going to do is vent the ballast tank. I think I can attribute that port list to the battery. I didn't put it in correctly. Well, anyway, I flooded the ballast tank, shaking out any bubbles just to be sure. We're just checking the trim here. It's a little heavy in the ass. And we've got that rather severe port list. It's not touching the bottom, but it's got a definite up angle. I don't like that. So now we go to blow. You might be able to hear it. Now you can hear the bubbles. While we're at it, I'll show you the propulsion here. Rather substantial. So anyway, here's the thing, when you're using a magnetic switch like that, even though everything appears to be off, there's an idle current going through the circuit, which is monitoring for the presence of a magnetic field. So it's an operation. It's drawing, just the barest fraction of an amp, but it is drawing current, and it's a load on the battery. If I left that in there for a couple of days, I'd kill the battery. So post-mission requires anyway that you open both ends of the cylinder. So I'm going to take this thing out of here, which is a simple matter. Disconnect those two magnets there. Out it comes. Now I can take a better look at things. Now let's see. Let's get a towel. Wipe that dude off. Take a good look. No water in the after dry space. No water at all in the forward dry space. And as I said, post-mission is to leave both bulkheads detached. Boom. That's the way we want to leave things. I'll let the hull air out overnight. I'll come back tomorrow and retrim this thing. Call it a night. Well, I finally had enough of that problem of this cylinder getting into this model. It was always hanging up on something. I found out this morning I finally had enough, and I got the problem down to the fittings on top. Remember those hoses? Well, those hoses had to go into a manifold, and that manifold was hanging up on stuff. Also, I had problem with the safety float valve. Its gooseneck, which made up to another manifold, was also an interference issue when I had tried to attach the hull halves. So I said enough of that. And also one more thing. I was starting to evidence some cracks. None of them had migrated over an O-ring, but I had some cracks down here. You can see it right there, maybe. Right here. See if I can get any closer. Anywho, I had enough. So what you're looking at is a fresh piece of 2-inch Lexane with a wall thickness of a 16th inch that's been annealed. I now anneal my own because apparently the industry has stopped doing that to save a couple of shekels during manufacture. Anywho, I'm depopulating this one. I'm going to populate this one, and I will embody the new design for the SAS ballast subsystem in that the hoses will not be external, they will be internal. So I'll be modifying this bulkhead and this bulkhead to make sure all the runs are internal and none of them are external. So it makes for an easier fit. I've already test fit this one that's been stripped of those projections. I've already put it in here, and I found that I can get the hull together with no sweat. Well, those were the culprits, so they're out of here. There we go. Notice this steady rest here, which ensures that the work is perpendicular to the sanding machine. There we go. Checking this thing. Yeah, it looks pretty good. So we're going to chamfer and bevel this thing. Bevel. And chamfer. There we are. So now the bulkheads will fit, hopefully, like so. All right, I've already marked off the cutouts, like for the vent valve and that sort of thing, using this stencil. As you can see, the stencil already has all the indications where I have to mark stuff, which has already been done. Maybe if I turn it right side up, it'd be more intelligent looking, like that. You see the marks? And there we have it. All right. So now it's just a simple case of machining, and I have a special set of drill bits, which are virgin to anything except Lexane. And that's important because it's the stress of the drill punching a hole that exacerbates the cracking problem. All right, here's the much improved Subdriver. If you recall, in a previous version, we had the SAS ballast subsystem hoses running on top, external of the cylinder, and they were getting in the way and making all sorts of problems. So what I elected to do was, as I have done in current versions, this was an older one, I put those hoses on the inside. You can see them right here. So that gets all that clutter out of the way. It's a lot easier to put the hull halves together and not hang up on stuff. Incidentally, I got this turned around. But you see it's been disassembled. This is the condition a cylinder is in after you operate. Even though you may not see water through the clear Lexane, it's good practice to, at the end of the day, take the cylinder out of the model, pull the end bulkheads off, and let it air out. In fact, that's really a favored storage condition. All of these Subdrivers for various models I have are all treated the same way. There are three phases of operating a cylinder, and that's pre-mission. Before you go out, you got to oil things up and check for operation. And then there's mission, which is what you do at the lake or the pool to maintain operation of the system. And then post-mission is what you do in the shop after, a day's play. You take everything apart, you air it out, you address any problems you found at the lake. It's maintenance and preservation and checks. So this is not a casual hobby. This is like real helicopters. For every flight hour, there's about 2 hours of maintenance and downtime just to keep it ready for the next flight. So that's the world of RC submarines if you want to stay active. If you don't take care of your gear, it's eventually going to break. It's not going to work. You might even lose the model to an accident or something. So anyway, that's enough of that. So what I'm going to do now is put the cylinder back together, and then I'll show you how the hull integrates with the cylinder and then button up, and then we'll do some testing in the test tank here. Because I did change the battery, which we changed the weight. I also made a cursory adjustment in fixed ballast weight to account for the change. But you're always off by a little bit, so I'm going to have to finagle a little bit. All right, so the first thing I want to do is push the motor bulkhead with its attached devices into this part of the cylinder. So that's a simple matter. I've already lubricated the O-ring with grease, silicone grease. So it's a simple matter to push this in, get it started. And while I do that, I rotate to make sure I'm not pinching any wires. Like that. See that? So very careful. You don't rush it. You don't want to cut any wires. You certainly don't want to trap anything under that O-ring, which will lead to immediate flooding once it goes in the water. Okay, something's hanging up. Nope, we're good. All right, so what I do, get this thing right side up, orient this correctly. And push it forward. Again, making sure I'm not trapping anything. Get it right up against the O-ring, against the edge of the cylinder. Before we slam it home, we take one last look to make sure nothing is going to go interfere and make contact with the I can see already that the main bus wires are in the way. So I'm going to pull back a little bit. I'm going to pull out that slack. Watch this. Okay, get that out of the way. And now we're going to go push that bulkhead back in. Good. Make sure this thing is right side up, like so. Good. The critical part here is, see, we got some wires now trapped underneath the limit switch. So we're going to go ahead and just rotate everything. Yeah, good. That cleared. All right, pull out the slack. Push things back in a little bit. Make sure we got clearance here, because that's the limit switch. And if it gets jammed by some of these bunched up wires in here, it's going to run the pump when I don't want it to run. So that looks clear. And once again, I'm going to make sure this thing's lined up, like so. Push it home. Boom. And now I rotated to make sure we didn't roll the O-ring. The O-ring's seated, that's good. And before I put the battery in, if I have a problem, I have to open up the back end again. I don't want to go through all this, so I'll just real quick get the battery hooked up and use a magnet to turn it on after I turn on the transmitter. Now the system. Good. Just the simple fact that now that everything's active, the pump isn't running, telling me that this limit switch was not jammed to push it against the arm, the servo arm here. Now how that works is watch this. See that? The servo arm acts as a cam in the blow position to run the pump. So that's working. Want to make sure all the other things are working. Differential for up and down, left and right. This collective. You can just see the operation of the dorsal rudder servo and linkage. All right, that's good. Now I'm going to turn off the transmitter and watch what happens. I turned it back on. The pump ran on loss of signal, and that's, if you will, your golden parachute in RC submarines. If the receiver is not getting the signal from the transmitter, then it will automatically command a blow. A very useful feature, and it saved my butt a few times. All right, happy with everything. I'm going to turn off the power in the transmitter, and I'm going to show you how I grease that cylinder. This is silicone grease. All right, you put the battery in, and there's this little spacer piece I made out of foam, and it's got a little step there to make room for the magnetic switch. You jam it in there, make sure it's sitting there nice and copacetic. Then you just do an ugly job of jamming all these wires in here. All that slack we pulled out had to go somewhere, right? Well, it's back here, but I have the room back here to get stuff in there. So I take the bulkhead, the forward bulkhead, and slam that dude home. For form's sake, we'll just put it in right side up. There we are. And again, we roll it to make sure we didn't roll the O-ring. We're good. This hose was there for testing. I already did in-water testing of the cylinder. And it is watertight, and it's functional, and ready for installation within the submarine. Notice no hoses up here to get in the way. But we do have one hose to make up, and that's the induction line, which is capped by a snorkel on the inside of the sail. And that comes out here. So all I have to do is make up this hose to the manifold, which in turn goes down to a T fitting so that the pump can either draw air from the snorkel or air from the inside of the cylinder. Which is a much easier operation than it was before. I don't have to jockey around all those hoses and stuff. Okay. Getting the indexing tabs all lined up. Pushing the two hulls together a little bit. There we are. Well, that's the long and short of it. The model has been completed, and after the modifications, particularly the replacement of the cylinder portion of the Subdriver, everything is trimmed out, cleaned up, post-missioned, and boxed back up in storage. We'll probably be using this for the first time this year at the upcoming Norfolk Harbor Fest event